Okay, today we are going to start talking about piecewise functions, and we're going to go through 4 examples to kind of give you an idea of the process for doing that. So the first problem that I'm going to do here is the following. So our first function is going to be linear, and our second one is going to be a simple parabola or a quadratic equation, where the linear function is defined for x values greater than 0, and the quadratic one is defined for x values less than or equal to 0. So the way that I usually do this is I'm going to find some closed and open points to help me kind of have an anchor point for where to start the graph. So here we know that this is an open point because there is no or equals to bar here, where there is an or equals to bar here, so this one will be closed. Okay, so if I look at this open point here, I'm going to use this as my x value of 0, so that's going to go here. And then if I take 0 and plug it into this x, I have 3 times 0 minus 5, which just gives me negative 5. So I have an open circle at negative 5. And the next circle is going to be closed, as we mentioned before. And again, I'm going to have 0 as my x value and plug in 0 here. But 0 squared is simply 0, so I have a point at 0, 0. Okay, let's just keep our color scheme here. Okay, so I'm going to indicate this first one with this blue or purple color, and then we'll stick with the green to represent the second one. So let's go ahead and set up our axes here. And we're going to again use these open and closed points to kind of help us get an idea of where the graph should start, right? So let's start with the blue graph here. So I'm going to start with a point at 0, negative 5, and it's an open circle. So I have an open circle at 0, negative 5. Now when you look at this, this is a linear function. The slope is 3. The y-intercept is negative 5, which you can see here. It's down at negative 5. It is an open circle, but we can kind of think of it still as the y-intercept. So just as kind of a side note here, if you think of slope as 3, right? M is usually indicating slope from the y equals mx plus b form. You can write this one of 2 ways. Okay, and this is going to be key here to help me draw the rest of the graph. So if you look here, I have up 3, right 1, because the slope is always rise over 1, so positive would be up 3, positive 1 would be right 1. Or I can say down 3, left 1, and that would actually get me to the same type of line that I'm looking for. So if I look at this guy here, this linear function, this only applies to the right of 0. In other words, everything over here. So if I were to use this version of the slope, from here I would go down 3, left 1, down 3, left 1. So I'd be getting into this region, which is reserved for the green space, as this indicates, to the left of 0. So instead I want to use this version, and I'm going to go up 3, right 1, up 3, right 1, and so on. So starting from here, I'm going to go up 3, right 1, so there's a point there, up 3, right 1, there's a point here. Okay, so that's just kind of a rough sketch. 2 is not actually a 0 here, but again, it's just kind of a rough sketch here. So that's our first graph in the blue there. And next we are going to do the green part. And we know that there is a closed circle at 0, 0, so that's going to be my starting point. Okay, and you know, it's kind of very useful actually to understand what these graphs look like. So this is a parabola. This gives the graph of a parabola. And so I'm going to use that fact to note that the graph is going to go like this. And again, I know that because usually the parabola would go all the way down and swoop down here, but over here I'm getting into the blue region of the graph, and I don't want that because the green region of the graph, because the blue region is on this side, whereas the green region is on this side. Now, a lot of people usually ask me, well, how do I know that this looks like this? Again, you need to know that x squared is a parabola, so you know it looks like that. But if you wanted any extra points, you can always plug in values to x squared to the left of 0. So for example, if I plug in a number less than 0, like -1 here, -1 in parentheses squared would give me 1, which you can see shows up on the graph right there. Okay, and you can just keep going. If you go to -2, you'd be all the way up at 4, which you can see does end up on the graph. So those are just some extra points if you need them to finish off the graph. Okay, so let's go ahead and look at another one here. So we'll call this one number 2. Okay. And for this one, we're going to start to work with, excuse my awful squiggle there, but we're going to start with an absolute value piece of the piecewise function. Okay. And then we're going to have a constant piece, and then we're going to have a linear piece. Very similar to what we just had. So the absolute value piece is going to be defined for values less or equal to 1. The constant part piece is going to be from 1 to 3, not including 1 and 3. And then the linear piece we'll say is for values greater than or equal to 3. So I'm going to go ahead and start off again by finding my open closed circle. So this bar here indicates that this is a closed circle. Okay, so just a similar process. I'm going to go ahead and take 1 as my x value, plug in 1 to this x value to get the y value. Okay, so I'm saying that 1 is my x value. Now if I plug in 1 to x, I have 1 plus 1 is 2. The absolute value of 2 is 2. 2 times -2 is -4. So I have a closed circle at 1, -4. Okay, this guy here is going to give me an open circle because there is no bar. And the x value is going to be 1 because I'm looking at 1 here. If I plug in 1 here, but wait, there is no x to plug in, so it's automatically 3. Okay. And similarly for this guy, I have an open circle. I plug in 3, but the answer is already forced to be 3 here. So I plugged in 3, there is no x, I get out 3. Okay, so I have an open circle at 3, 3 as well. And then we'll say this guy down here is a closed circle as well. Okay, and it's going to be closed at 3 because of this 3. Plug in 3 to here and you get 0. Okay, so I have altogether 2 closed circles and 2 open circles. Okay, now I'm going to try and do the same thing here and do different colors. So we'll make this one blue. Let's make this one red or pink, and we'll stick with the green for this guy. So let's go ahead and get our axes set up here. And again, we're going to use our closed and open circles kind of as anchor points to tell us, okay, well, where in the world should I start with these graphs? Okay, so let's start with the blue guy here. So I have a closed circle at 1, -4, which is right there. And now let's think about this absolute value function for a second. So first of all, it's an absolute value function that is upside down because of the negative. So I know it's to the left of 1, it's going to go something like this because it should be opening down. Again, thinking about the transformations, this is a reflection over the x-axis. I also know that the vertex is at -1. Okay, because if you plug in -1, you get 0, and that's actually going to be the highest point that this graph reaches. Okay, so and also you can get that just by plugging in some points, and eventually you'd see that -1 here will get your highest value, and then it starts to go down. Okay, and let's pick another point like -2 to get a point over here. So if I plug in -2, I get -2 plus 1 is -1. Absolute value of -1 is 1. 1 times -2 is -2. So I have a point at -2, -2. Okay, so I know that the graph makes this V shape because I know how absolute values behave, which is something you need to be aware of in order to do these to make it a little easier on yourself. And you can see that it stops at this point because at 1, something changes and it goes to this constant number. So let's look at that one now. Okay. So I have an open circle at 1, 3, and an open circle at 3, 3. And this one's very simple, actually. So everywhere the y value is 3, which just gives me simply a flat line between 1 and 3 in this case, okay? And so that's the middle part there. That's pretty simple. You can think of it again. It has a slope of 0 here. So there's no x. Y is always 3, okay? And then lastly, let's go to the green one. So the green one had a closed circle at 3, 0. Okay. By the way, you can double check that you're drawing an actual function. So if you see here, there's no overlap. Even where the holes are, I have an open circle on top of a closed circle, so I'm good with the definition of a function. This x value is exactly one y value, and it's here. This is not actually a point. We just kind of mark it to say, okay, once I get here, boom, I jump up to here, and then I jump down to here. So if we finish with the green one, again, this is it's not in standard form, but you can see that the slope is -2. It's the number in front of x. So going back to the previous problem, if you think about m being -2, well, that's the same thing as -2 over 1. Right? Any number you can put over 1, which is the same thing as 2 over -1. So I need to figure out, okay, which of these slopes should I use? They are equivalent, okay? But which one's going to be beneficial for this graph? So if you notice, this is to the right of 3, so I should be going this way, okay? You can also see that it is a negative slope, so actually not only is it going to be over here, but it's going to be going down as you read the graph left to right. This should be going down. So if I were to use the up to left one version, I would go up to left one, up to left one, up to left. So you see I go into this region that I already have a graph. So I'm going to use this version here and go down to right one. So from here we go down to right one. You only need 2 points to make a straight line, so that's good enough. And this is our resulting function for this piecewise function. Okay, so let's continue with a third one here. We're going to get through 4 of them by the end. And the third one we're going to call g of x, and we're going to say that it is made up of this linear function. The simplest of absolute value functions, actually the parent function of absolute value functions. And then another linear function that just has the opposite slope from the first one, okay? And we're going to define this first linear function for values left of, including -3. We're going to do the second one between -3 and 3, not including them. And the last one we'll do, you can kind of guess, x greater than or equal to 3. Okay, so let's just go through our process here again of finding our open and closed circles. So this one will be closed because it has an or equals to bar right here. And so if I plug in -3 as my x value, if I plug in -3 here, I get 3 times -3 is -9 plus 12 is +3, right? So I have a closed point at -3, 3. Okay. Next, I'm going to have an open point here at -3, and then I'm going to plug in -3 to the absolute value function, which just makes -3 positive. And here, excuse me, crisscrossing of lines, we'll also have an open point at 3, 3. So here, I plug in 3 as my x value, I get out 3, okay? And then finally, to finish it off, I have a closed point at 3, again using this 3 as my x value, and plugging in 3 here, again I get out +3. So this one's kind of interesting because you're going to see, for example, this last one you did, 3, 3 is both open and closed. So what does that mean? How do I indicate that? So we're going to talk about that once we get to that point. So again, let's stick with our colors. We'll make this one blue. We'll make this one red, and we'll make this one green. All right. So we got our nice colors here. Let's go ahead and set up our axes. Okay, and so let's go ahead and do this blue guy first. So I have a open point, or excuse me, a closed point at negative 3, 3. Okay, and again, this time I'm not going to go through the same explanation as the slope here, because hopefully by now you're starting to catch on. So if I want to look at a slope of positive 3, I don't want to go up 3, right 1, up 3, right 1, up 3, right 1, because that'll get me in this region, whereas for this graph is meant to be in the left region of negative 3. So instead, I'm going to go down 3, left 1, down 3, left 1, okay? So here I'm going to go down 3, left 1 puts me here, okay? And this is a straight line. Just a note on this here, this arrow does not mean that it's a negative slope. In fact, this line has a positive slope. The arrow simply means that the line extends in that direction. But remember, when we read graphs, we read them left to right. So left to right, this is going up, so it has a positive slope. Even though this arrow is pointing down, that does not tell you anything about the slope. Left to right, the slope for this is positive, okay? Next, what do we got? We got the red one. So this is where I see an open circle at a point that I already have a closed circle. So the way I'm going to indicate that is like that. So an open circle with a closed circle inside. Okay. Again, it's helpful to know the absolute value function is a V shape. There is no transformation here, so it just goes through 0, 0 and back out. Okay. Before we do that, let's go ahead and put the other open circle at 3, 3. Which you can kind of guess we're going to be filling in for the third one, the third green function. And now it simply goes like this, following the parent function for absolute values. Okay, again, no shifts, no translations, or excuse me, no shifts, no reflections, no stretching, nothing like that. Okay, so there's our middle one. And lastly, if we look at this green guy here, we have a closed circle that goes now inside this open circle. And looking at the slope, it's negative. So again, what I referred to left to right, this should be going down. That's a negative slope, left to right. So I have the option of either going down 3, right 1, down 3, right 1, down 3, right 1, which you can see works because I need to fill in this region. The other way to do it would be up 3, left 1, up 3, left 1, up 3, left 1. Okay, but that's not going to work because I already have graphs over here. So normally, if I were just to graph the green one, I could do it either way, but I need to do it this way because this already has functions in its area. So I'm going to go down 3, right 1 to get this function. So it kind of makes this cool sort of M-looking shape in this case. Okay, and so there you have g of x, this piecewise function. Okay, and now let's look at our final problem here. We'll say number 4. And this one I'm going to call h of x. Okay, just to mix it all up a little bit. Okay, and we'll say the first one is going to be a quadratic function with a shift down 4. And the second one will be a linear function again. Okay, and the first one we'll say is defined for x less than 3. So I've been using a lot of 3's today. And x greater than or equal to 3 is the domain, if you will, for the second one. Okay. So by now you should know the drill. We're going to go ahead and find our open and closed circles. This is open because it does not have a bar. If I plug in 3 here, again using parentheses, right, just in case we have negatives, that way we don't have to worry about it. So anytime you evaluate, or in other words, informally, you say plug in, right, and number for x, use parentheses. So 3 squared is 9, 9 minus 4 is 5. So I have an open circle at 3, 5. And then I have a closed circle at 3. And if we plug in 3 here, 2/3 of 3, the 3's cancel, so I'm left with 2. And then minus 5 is negative 2, right? So in other words, let's do this real quick. 2/3 of 3 minus 5. These cancel, so I have 2 minus 5, which is negative 3, right? So let me just erase this real quick. So we have room for our graph. Okay, so we have, what was it, negative 3, right? And so let's go ahead and get our axes ready. So we're all set to go. And we'll go ahead and indicate the first one blue like we normally do, and then we'll do the second one kind of this pink color. So let's start with the blue one. So we have an open circle at 3, 5, which is up here. Okay. Now this is quadratic, but it's shifted down 4. So normally, let me show you what it would look normally like. Usually it would go like this, right? And it just goes through the origin, okay? But now I'm bringing this guy down 4 units, okay? So the new graph actually looks like this. It goes all the way down to -4, which is the vertex. And by the way, you can find that again by plugging in 0 here. 0 squared minus 4 gives you -4. And eventually you would find, if you weren't sure, that that is the lowest point. Some other points you can plug in are 2. So 2 squared minus 4 gives me 0. So there's another point. And then I can do the same thing on the other side. That's the nice symmetry. -2 in parentheses squared minus 4 is also 0. So I plugged in another point right here, -2, into this x squared to get this point here, and the same thing here. So I have this parabola, and let me do a little bit better of a job. It's a little better. So there's our parabola that is shifted down 4 units from this transformation. Okay, and then lastly we have this nice linear function here with a slope of 2/3, so up to right 3, up to right 3, or down to left 3, down to left 3. Okay, and let's start with the closed circle at 3, -3, which is here. Okay, so I can either go up to right 3, up to right 3, up to right 3, which is the one I'm going to use because I need to fill in this place. The other way you could go is down to left 3, down to left 3, but I already have a function in this region, so I don't want that. So I'm going to go the first way I said and go up to, and I'm going to need to add extra dash here. So if I go up to right 3, let's see, I end up here. Okay, so that is the linear function, and you can see that in this case there is a pretty big jump between these 2 points. You could also have this point over here, and then maybe this one starts over here, so they don't necessarily have to be, you know, right where one stops, the other one picks up. Okay, you can have some gaps in between, but most of the ones we've done just kind of have this nice overlap here, sort of, if you will. Okay. Okay, so those are some examples of piecewise functions. Hopefully this is helpful to you guys, and thanks for watching.